All right, guys, welcome back to the channel. I have another interesting video here. This is in a 2004 Toyota Camry ECM. Customer concern is one of the solenoid B on the transmission not working properly. The computer is already repaired, and I want to show you just uh, briefly how I went to the repairs, how I got the information, which I got on the screen right there. And now a few tests that I want to share with you all about the curve tracer. This tool I have from a Ukraine company is really good tool. You can see the tool in there is a UCE dash or underscore. I don't know how you call that one dash CT220S. Really good. I have a whole video describing the use of this curve tracer. I will go a little bit on what I'm using it and how I'm using it here. They have actually a new firmware that come out just not too long ago, and it's actually working really good. All right, going back into this computer. Again, it's a Toyota Camry 2004. That is the part number. I mark the connector's number, so it's easy for me to get the pinouts. Um, as usual, you know how I do my homework. I go over to Identifix pretty much. I even have a few information thanks to Brad Davis that posted this on Identifix and put this and posted this and says it's a mechanical. Well, yes, most of the time that can be true, but you can see in there it says code P0776 pressure control solenoid B performance shift solenoid valve SL2. The gear required by the ECM does not match the actual gear when driving to trip logic. This is a mechanical code, not an electrical code. Yes and no. Um, yes, it's most of the times about body, and he's correct in that assumption, but it's not 100% of the time. So these ones is also, it's a chip solenoid. If by any chance the chip solenoid is shorted, because higher amperage is going to end up damaging the computer, and that's exactly what happens in this case. Let me start the screen recording. All right, since I have now the screen recording, I can set the camera here, and you will be, and I mean, this is just fantastic view of what I will be doing with this test in here in a second. So again, you are seeing on one camera there, and I will be recording the screen here. So we can all talk a lot better when I am in the screen and I just doing some descriptions. I will be just putting this as a main camera and probably just a small windows on the tab for this too, but we'll decide that later. All right, so again, as I was saying, thank you, Brad Davis, for this very good information. Again, it's not 100% bulletproof, not always is mechanical. Going into the information, a lot of pops out from my family. I always like to um, see what the DLC connector information is because remember, manufacturer, you got always in the DLC manufacturer specifics lines, and this is the case with this computer. This computer is, even though it's a 2004, it does not communicate in CAN high and CAN low, and I will show you that also as we go along with the whole information. All right, so I think I got, yeah, these are the terminals for the ECM. And again, this is very nice because it's actually the connector of the computer as we see on the screen. That's the same as we see here. That's what I put E6, E7, E8, E9, and E10 as we see there. And the rows are exactly as we have there. So I went ahead and mark the solenoids in here. And the reason I have transmission 1 and transmission 2 is because as you can see right here on the tab, it says U15E1. There is also, if I go, this is still the U15E1. Let me actually close this, and because I know I have both connectors, that should be right here. Yeah, so we have transmission U24E1 and U15E1. And the pins are different. The only real difference that we have, let me make this bigger so we can all see again, same pinouts, that doesn't change, but in the PCEV transmission, if we go down to terminals in E9 for the, SL1, Let me just go there, SL1 or SL2. Yeah, if you see right here in SL1 and SL2, we have, which are the solenoids that we're talking right now. Um, we have pins 16 and 17, and then pins 18 and 19. But if we go over to the pinouts, and I'm going to open the order transmission, now we have, this is the U15, which is not a PCEV emissions wise, right? So if we go down to that same SL1 and SL2, this has also an SL3. You see right now SL2 is in pins 14 and 15. So which one is? Because it's also talking about, it has a SL1 in here too, 18 and 19, and it talks about an SL3 and 16s and 17. So that's why I mark, again, if we go here, we only have SL1, SL2, and S4. And this will have also SLT. Let me see if I find that one. Maybe not on this transmission. Oh no, it's right here. The SLT. This is just the solenoid signal, and it tells you. If you read, this is very good from Toyota. Right here on the right side, we got pulse generation 5, pulse generation 6, pulse generation 1. What is that, right? Well, it's actually right here too. If you scroll down, keep going down. It's a lot of information in here, which is really, really important and really good. All right, this is where we got pulse generation 1 reference. Like in this case, SLT plus and negative is telling you in this capture they tell you what is ground or zero line, right? And then that every single of these divisions is a 5 volts per division, and then on the bottom is a 1 millisecond per division. Great information. This is oscilloscope signals. So we can check that, and that cannot be applied here because we need a car in order to check these solenoids. Not like in Hondas that you can actually click the solenoids on and off. Toyota doesn't allow that, and I tried with two different scanners, and it was the same result. And I'll show you in a second at least pictures of that because I was working on this computer yesterday until 11:30 at night. I'm a workaholic, a lot of work to do, so I had to catch up. And also trying to go to a wedding tonight with the wifey, and so I have to catch up. All right, but yeah, so all those reference pulse generation 2, 3, 4, all those are in here, and they're telling you what they are for, how they should look, and that is great information. At least now you know that you have a known good waveform. Is this the way it should look? Yes, it's exactly the way it should look. So perfect. So again, and that's why, if we see this picture here, that's why I mark SL1, the SL1 is in all the computers. The SL2 is in different locations, depends on PCEV, yeah, or not. So we will find out in a second an easy way to know that with the curve tracer. Going back into the information that I have here, what else do I want to share with you? I also, got the color wire diagrams, and I always download this. I have the DLC connector. If I go over to page 2, you can see that I am now very, very familiar with the actual information because I do my homework. So we have in the DLC what they're showing us in here: TC, SC, SIL, SG, tag, and F. Sorry, WF, SE. Again, Toyota denominations. And if we follow these lines, like let's say, if you follow WF, SE, it goes straight to the engine computer on page 1. We can see that here. If we go over to that red wire right here, it's in pin 10. If I go back to page 1, and we follow pin 10, it's the same WFSE. It doesn't tell me what exactly that is, but I know it's a communication line. And that's what I also, by knowing that, I put on a separate page. I do my notes. I have everything simplified here, so I can check because I can communications are an E6 connector, E6, right? E6, E7, E8, E9, and E10. There is like two empty spaces in the middle of this computer. So E618 goes to DLC7, E619 goes to DLC 15, which is a very manufacturer specific. Actually, 13 is manufacturer specific. E6 go to 20. So you can see that in the image. I did provide all the grounds and powers, ignition, and wake up. And these are the solenoids. The computer is actually in control of both power and ground for the solenoid. It's a very intricate, very well designed, sorry, very well designed system. But as everything, I mean, if you have a shorted solenoid and you keep driving and driving with a full code, it will eventually damage the computer. So that's what I said. Yes, it's mechanical because that solenoid is binding. So as I want to go back to his name, so I always said that correct. As Brad is saying in here, yes, this is mechanical. And it's starting as a mechanical jamming in there. So fix your transmission, change the fluid, change the solenoid, because now mechanically that solenoid is binding. And what is happening now that the solenoid is binding, the amperage is increasing. So when it start to draw, let's say, 1 amp or 2 amps or whatever that solenoid draws, now it's drawing 5 amps and then eventually 8 amps and eventually 10 amps. And now it's overheating and whatever is the weakest is going to go. Fuses, no fuse. The fuse is right here, the computer. So that's why it's so important to fix that before it's too late. Um, luckily, or not luckily, the design that this computer has for that system is so robust that is 100% repairable. I have all the parts, even though this is a 2004, it's still in use up to date. So I have, they have very strong drivers and pre-drivers for this system. Toyota is really well built. All right, so going back to the information, so I don't lose the sight of what I was trying to share. If I go back to the DLC connector, then we can see that 7, 13, and 15. 15 is L line, obviously 7 is K line, but then 13 it says manufacturers. We don't know what it is, but we know it's a communication. So that's why I also like to see, do I really need that or no? I have another one in here for again, this is from the website. This is thank you to eTechnology. Yeah, it's just a picture describing what that is, and but it says nothing about the pins. And I was looking for 13, so I also say that the VIN number of the vehicle not important for what we're doing. Again, I have more of the wire diagrams. These are the original wire diagrams, and I keep everything as a one piece. Like that, I understand what I'm seeing. And as you can see here, we got S4, S1, S2, and SLT. And this is for, I don't know what this one is. Let me see it. But if I go over to the next one, now we have S4, S3, S1, S2, and SLT. So four more solenoids. This is not really a solenoid. This is for, well, it can be a solenoid. It's hard to say. I'm sorry. I knocked the microphone. Because this is a very I don't know, basic image. It looks like a coil, so it looks like a solenoid. We have the same here. In this case, the transmission is grounding. This one's through the case, and these ones are going to the engine computer, which is the same transmission computer on this vehicle. For the way that this is drawn, this tells me that this is a temperature sensor. So this is definitely the transmission temperature sensor. THO1 is definitely a transmission temperature sensor. And on Toyotas, all the E's are ground. So you see E1, E2, E3, E4, E5, whatever numbers up to, whatever Toyota wants to do, as long as it start with E, is earth ground. All right, so, or ground. Okay, going back to more information. What else do I want to share in here? I always take myself a picture with, for the boards, because this is a high um, definition picture that I can zoom in, as we can see here, right? So you see how much I can really zoom in. I can see nicely from Toyota. It tells me what C902, C4, whatever, all the capacitors, if it's a resistor, if it's a diode, because R is for resistors, C for capacitors, so it's very easy to um, kind of like get an idea of what you're dealing with, because D, a diode, R, a resistor, T is usually for transistor. Some manufacturer uses a Q as well too. I'm trying again to share as much as information for those that are around there, or for people that really wants to and is interested in seeing stuff like this. So I like to share that. But yeah, as you can see, you can almost see the numbers on all the capacitors and transistors and everything. So I like to do that in everything that I work on. Same thing for the other side. And then what I also do, let me just right here, is I mark. Again, I do the markings on the connectors in here, and then I start follow the lines that I'm working, like in this case, the pins 14 and 15s, and then following and see where they go. This one goes to this pre-driver, that's this transmission pre-driver, and this is the part number for that transmission pre-driver. So this is just one part of, like, one of the legs for that transmission. The one is on the other side. But yeah, so that's how I reverse engineer. I even before I used to draw and paper and then take pictures of that. I also got now an electrical um, software that I can draw in there and put capacitors and transistors, and it's more uh, professional, easy on the eye too, and I start to be just drawing and using a ruler, less time consuming. But then I also find out that this is actually a faster way to do it. I just take a picture. Why am I have to draw a whole circuit if I already have it here? And if I want to do something else, like um, like explanations, I usually put an arrow, and that's what I always take a picture, an extra size picture, so I have sides on the picture, and I can draw or put a picture or a diagram on the side about the pinouts for a specific I see, like this one or so, if I find it, because sometimes you cannot find. These ones we know they're definitely a pre-driver, a very strong pre-driver. It has a very heavy ground path. So is this one, so is this one. So these are definitely drivers. So, sorry, pre-drivers. Some of these ones are going to have the MOSFETs or IGBT, depends on what they're dealing with, built in, and some are also externally. All right, so again, this is another information that I want to share. So we got the pinouts in here, and okay, the pictures of me testing that yesterday. I did took a picture to share with you guys. This is I was using just a small box that I usually put in here, and providing powers and grounds and checking the solenoids with it. Um, Tap done, not possible. All I was getting was just the power. The problem is, let me just zoom in. You can see 11:34 p.m., 10:07. That was yesterday, and I'm still a little tired from that. But yeah, I mean, I like. Okay, this is actually a better zoom. But yeah, you see, I was actually in that page, and you can see Camry 2002, American, Toyota, blah blah blah, PCEV. I was trying PCEV or not PCEV to see if I can get the solenoids to activate, but they have the same requirements. Vehicle on, engine on and 30 miles per hour, or park and neutral. So it was too intricate to do that. And now, since I could not do that test in there, and that's what I have now, um, the curve tracer in here. And this is the nice thing about having um, TeamViewer, is that I can use that computer in here and we can all see what I'm doing. So with this curve tracer, you have two outputs, probe one and two. So you can actually, if you have two computers, you can record or test a knowing good with a maybe not working computer, and then you can check each. You can also connect an oscilloscope. If you don't want to use this software, you can connect an oscilloscope with this output, X and Y, and then use it, like picoscope can do it. Um, I like the software because with the software, if I want in advanced mode, as we can see here on the tab, this advanced mode, I can, like, I already have a picture of the computer, and I can record if I want the entire computer, and then have a good database. I can see how the signal should look. All right, so without further talking, let's show you something. So I always check my equipment. So when you have an open line, that's what we have, a flat line in there, that means open. I also adjust these settings, the resistor, the internal resistor that I'm using for this test, the frequency that I am using for this test, and the voltage that I'm using for this test. It all depends on where you're testing. If you're testing a big capacitor, you might want to use a higher voltage and a lower frequency or a higher frequency. The same computer is going to talk to you. And what am I saying about that? Like a lot of people talk, okay, how you are, show me. Or that's exactly what I want to do, right? So I go into a ground into, all these electrolytic capacitors. The black line means ground. And I know that this, by looking at my connections, E81 is a ground. And I'm not touching anything else. So if I touch in here, this should go up straight. And it did. Well, this wire sometimes does the little weird shit. Oops, sorry. That's a little weird thing. Okay, so that's a short. That's what you will see if you have a short. That means it's ground and ground, or if you're not touching the ground and you see that IC, that transistor is shorted. All right, so I check then the other side of the transistor, and I should have kind of like a circle around, right? That's a capacitor, perfectly beautiful signal. And then I adjust because if I change the settings, I will get different images. So you want to see, like, I can see that this capacitor right here is not in the same ground path. That's why we got that. So that kind of like circle different weird signal is telling me that this capacitor specifically is in a different ground. If I go over to the other, you see how it's a kind of like a balloon look, and it's not that it's anything wrong with the capacitor. Remember, I am in this ground. That ground is now telling me that it's not supplying a ground to the entire computer. But does it supply ground to the components that I want to check? I want to test that. So if since I'm going to check this in here, I want to check that that ground perfectly shorted. So that means that this IC is sharing the same ground as A1, sorry, A8, E81. So I can do the test that I want to do in there. All right, so I know now by looking at the pictures that we have that this pin 15 goes here, and that's definitely what I'm looking for, and then it goes right here. So this is one of the outputs over to that solenoid. Then the other side, I gotta be careful when I do this so I don't short anything. We'll go over to here and to here, and then from there goes to this one. Let me just make sure I'm touching the right pin, because that goes through here. Perfect, perfect, and right there. So this has a very strong clear code in the computer. So those are the signals. Okay, now you're going to tell me again, and you will make a questions. Okay, how do you know that that is the actual signal? Well, I actually went and inject the signal and then follow the path, or I use continuity and follow the path until I know what am I looking for, right? This is a very specific repair. So now for the actual part in question, let's go over to that information and here. So I want to show this is E9. So I will go now into E9 here. Make sure that this is perfect. Yes. All right, I'm going to go into E9 and I'm going to be touching these ones, all those 6 pins. Again, those are the concerns. I'm not going to repair the entire computer. I'm going to repair his concern and that will take care of his problem, right? Again, I'm not changing the wheel or reinventing the wheel, I'm not redoing the wheel, not reinventing the wheel. Uh, early, just woke up and I'm tired. All right, so going back to the software. So we know that we have in the second row are the last 6 pins on connector 9. So I'm going to touch the 19, and that looks pretty much almost like what we had before, right? So perfect, because he only has one concern. It's P0776. So I'm going to touch now 18, and we got a little circle. Huh, that was almost what we got on the other side of the board, right? Guess what? That's exactly what you're looking for. That is exactly how you test your, if you cannot do an activate actuation, because before I have what I'm going to show you now. I'm going to pins 14, let me see, 14, 15, 16, 17, 16 and 17, nothing, and nothing. You know why it's nothing in there? Because this is not a PCEV, or it's not, let's not just say PCEV. This is not the U15 or the U24. So it's either one of those. But I know now that this doesn't have the center output, because this is open and this is open. But then this one, now I'm in pin 15. If I compare 15 with 19, which is positive to positive output, those signals, they look exactly the same. If I go over to 18 and I now touch 14, they look exactly the same. Done. I'm done. I know that this computer is going to be plugged into the car and it's going to run perfect. So again, you don't want to over test, over do a repair. If you all have time and you want to, again, map out the entire computer, good for you, because the next time a computer that has a different issue comes, now you're going to have all your information. And this is how I do it, recording it, saving it. Uh, Now talking and going back, since this is all I want to share with this computer. Now let's talk a little bit about this actual software in here with the UCE CT220S. That's, I think, the yes. From Ukraine, the curve tracer is called the U-Core. It's really, really good. Just look for online for U-Core or put the CT220S. It's really good. Things that I like about this is now, if I go over to a capacitor, look at the reading on the upper left corner. It's telling me it's 105 microfarads. It's telling me the resistance. That is actually awesome, because you know what? That might help me find a part that I have no markings. Like in these ones are not really a problem. Let me try to look into one that I can actually see clearly. Because remember, all these capacitors, even though they are have markings, those are like codes that you have to look online in order to get the definition. And sometimes you want to, sometimes you can, sometimes you cannot find anything. But this one is definitely a capacitor. It's 125 microfarads. So let's try to read a resistor. These ceramic capacitors in here, these are the ones that are very hard to know when you are testing a computer, because they got no markings, they got no uh, polarity, but they do have a value. I'm trying to read it. See, this is in series with something, and that's why I'm not getting a reading. And that's why sometimes even things like this, okay, right there, 125 microfarads. The best way to do this is to check this component off the board, or use that tweezer that I have also in my two reviews, because that's very accurate. It puts a very small voltage, and that will not activate any other capacitor or anything that is around, and it will just test that component. That's why it's so important to have different tools. Depends on what you're trying to do, right? So this is why I like this tool a lot. It tells me values, it tells me resistance, and I can go into advanced mode, use that picture that I just got here, and then I can actually just start to talk. Let me just grab that photo. We're on the upper side. I mean, we're here, right? So I'm gonna copy that picture because I'm working on different computers, and I'm gonna move it over to this side. That should already be done. All right, so advanced mode, enable that database mode. Um, Let me just add delete move because it's been a long time I don't use it with for this feature. Name included, yes. This will just add a test point in here. Let me just delete that. Let me load the image. All right, so and let's load a image in here since we just put that one in the desktop. Okay, so this is the nice about this. So what you want to do is you can magnify here like your X, right? If you want to have a chore better or just that um, let me make this bigger. So if you just, in this case, you don't want to have edges on the image, you can just cut it and make it exactly. You can even remove the connector like that. You have only the board, and then you have a better view of where you're pointing. Because let's say, we're going to try and test this point in here. So let's do less magnification so we can see that pin because it's better view on upper corner right here than what you can see here. We can make that the size of that smaller, so we don't need to be that big on the board, and the thickness is smaller as well, and that also does it in the upper one. All right, so non-show points, non-tested, recorded, red, black, and green. We can change the color of that, and that makes it easy for you to see or not. So we are actually in the pin that we can check. So now that I put that in there, I am going to come in the microscope because again, I don't have my glasses on. And those three pins are the same, so I can just touch in here and I can add. So I can add this, right? So, and I can save it. So I can put, like Camry, enter, and that is saved. I can also, that is saved for future references, and it will record the image and everything that you have, but you can see it's right there. So if I want to touch a pin, I can do a test. So enable database mode. So I can check in here. Let me make sure, yeah, the audio warning is in there. I'm going to touch something else. Let me see, move upload, enable database, tolerance. I don't see a percentage in there. Auto test. No, I don't want the auto test. It's because of the laptop you cannot hear it, but I just went like almost like a whistle, like a that means no. If it pass and is the same, yeah, this microphone is gonna take it goes like bam. If you have because I mean that is exactly the same image. So again, since I saved that point, we have now on the screen a known good signal. So if we check another signal, let's say like I did before, okay, let's go over in the front, right? So we're gonna go over to E19, and as like I said, it's pretty much the same, right? I'm gonna go over to E15, E915, and it's exactly the same. So perfect. I can save the other signal because the other signal is going to be on the other side of the board, but let's put a test point someplace else. The computer, again, this is your doing, not the computer, not the actual software. So you can put this pin into or this mark into anywhere you want, and the computer will come back to there. I'll show you that in a second. So let's just select that one, and we can touch the other. side of that. I'm gonna use the pin 18. Oops, sorry, pin 18. We're gonna add. Let's see, add this point two. Oh, did it save it? Yes, I did, right? Yes. Yeah, right there. So we got now test point two. If I go over to, that was in pin E918. If I go back to pin A14, so 18, 15, 17, 16, 15, 14, does it look the same or what? It's an image. It's a copy of that one. I'm going to go over to 18. It's exactly the same. And now with this test, since I have all those test points in there, you want to create test point one, you can name it if you want, like a pin IC number, whatever you want, and then pin one, pin two, pin three, as whatever you want, and then you can save it because the nice thing about this, since an image is loaded, when you come back, if I touch right now point one, you see where the arrow went? Right back to where I put that. So if you're careful enough to put those where you need it, you don't have to put names. You don't have to put numbers. You just test one and two, it will be a lot faster. But if you want to add it and pin one to 40, pin one to whatever, you can do that too. So and as you see, by me going into this point two, the mark goes to here, the cross, and the save image is there for you to test. This is a very, very good time consuming tool that will save you so much time. You can share, like I always said, apples to apples. You have a knowing good computer, a knowing good waveform, a knowing good image. It can tell you, is that IC bad? Maybe yes, maybe not. But you at least have now, okay, the signal is the same, the signal is the same, the signal, oh, it's not the same. Now let's check the circuit from the pin all the way back to the microprocessor, the pre-driver, the MOSFET, the coil, the anything that is on the circuit. So this is, like I said, is a really, really good tool for those that are working on this. Forget about any other curve tracer you find online. This is for me the best you can get for the money, period. Plus, their support is top notch. I have a problem with this one, which I bought 2 years ago, almost 3 years ago, and they were immediately answering, yes, this is most likely. They send me even the drawings on, like wiring diagrams, and they say, check this, values should be like this, and if they're not, most likely your amp is bad. They give me the part number, I order a mouse or electronics, done deal. So if you got one of these and it's not working, don't throw it away. These are great tools. I can fix it for you. Just send it over and I fix it, or contact me again. Send me an email, Mike at MikeSalazarDiagnostic.com. And I always said Mike, and I know my name is spelled differently. It's the way Costa Rican sound for Mike, M-A-I-C. That's the Spanish. So Mike, that's what we all everybody calls me Mike. But yeah, it sounds like Mike, M-I-K-E. All right. Okay, guys. Again, thank you so much for visiting the channel. I want to share a little bit of this. I want to share also this for Manuel Pinto in Leesburg, Virginia. Your computer is good to go. I will be contacting you shortly in order for you to come and pick it up. He is local, so he's most definitely going to be here in a minute. Thank you so much for visiting the channel. Don't forget to subscribe. I really appreciate if you can click that like and share my videos. That really helps grow the channel. It makes more people view my stuff, and it helps me grow. Thank you so much. See you next time. Bye bye.